bass, mash up the place.
A geometric progression is a sequence of numbers in which each one is found by multiplying the previous term by the same number. The first term is called A. The number we multiply by is the common ratio, R. We also need to specify a number of terms, N. If the magnitude, or size of R, is greater than 1, then the terms of the series will get larger and larger in size and head off to infinity. This is called diverging. If instead the magnitude of R is smaller than 1, then the terms of the series will get smaller and smaller in size and get closer and closer to 0. This is called converging. The sum of the terms of a converging series get closer and closer to a fixed amount called the sum to infinity, because you would need to add up an infinite number of terms to actually get there. There are three formulae using A, R and N. The nth term is given by un equals AR to the n minus 1. The sum of the first n terms is given by Sn equals A times R to the n minus 1 over R minus 1. But if R is smaller than 1, you might wish to use an alternative form. And if the sequence converges, there will also be the aforementioned sum to infinity, S infinity equals A over 1 minus R. Here is a proof that Sn equals A times R to the n minus 1 divided by R minus 1. Firstly, we write out the sum. So S equals A plus AR plus AR squared all the way up to AR to the n minus 1, the nth term. Then we multiply by R, so we get RS equals AR plus AR squared all the way up to a final term of AR to the n. We subtract the first line from the second to get RS minus S equals AR to the n minus A. Then we factorise both sides, so we get S times R minus 1 equals A times R to the n minus 1, and then we divide both sides by R minus 1. Example 1. A GP has a third term of 315,000 and a sixth term of 8,505. Find the difference between the sum of the first 10 terms and the sum to infinity, correct to 3 decimal places. For step 1, we use the nth term formula to find expressions for the third and sixth terms. In step 2, we then divide these terms. The a is cancelled out and leave us with r cubed. If r cubed is 0.027, then r is 0.3 by cube rooting. In step 3, we substitute r back into one of the expressions to find out the value of a, and a is 3,500,000. For step 4, we work out the sum of the first 10 terms using the formula a 1 minus r to the n over 1 minus r. And then for step 5, we work out the sum to infinity, and then we subtract one from the other to get a final answer of 29.524. For example 2, the first 3 terms of a GP are x minus 3, x plus 3, and 3x plus 4. Find S12 given that the series diverges, and give your answer to the nearest integer. So, since we have 3 consecutive terms, the common ratio will be the second divided by the first, and also the third divided by the second. So for step 1, we can put these fractions together and put them equal. Step 2, we cross multiply and divide, and we end up with a quadratic equation, for which the solutions are minus 1.5 or 7. In step 3, we need to decide which of these is the sequence that diverges. So we substitute our minus 1.5 in, and get minus a third for the ratio, but that doesn't diverge. And then we stick in 7, and we get 2.5, which does diverge. And in step 4, we work out what a is. We know that the first term is x minus 3, and x is 7, which means the first term is 4. And then in step 5, using our ratio of 2.5 and our first term of 4, we can find the sum of the first 12 terms is 158943. The end.
Rude boy bass, mash up the place.